Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started a discussion with our chapter Hyperbola. What did we learn? We started with what is hyperbola and the problems of it. Today we are going to discuss mostly about tangent of a hyperbola. Okay. As we discussed before, let us assume y equal to mx plus c as a tangent to the hyperbola x square by a square minus y square by b square is equal to 1, right? So just we'll equate it and find the condition that equation is a tangent to this hyperbola. How did we do? Just we will take let p of x1 comma y1 be a point. So what is the equation of tangent? Equation of tangent is s1 equal to 0. How do we write? Xx1 by a square minus y1 by b square is equal to 1. So let me write it in the nice form. Xx1 by a square minus y1 by b square minus 1 is equal to 0. Is it? Here also we'll write it in the form of mx minus y plus c is equal to 0. Now here equation 1 and 2 represent same. Yes, this is also a tangent, this is also a tangent. Now equation 1 and 2 represent same, right? Then we'll just equate the ratios. X1 by a square by m is equal to minus y1 by b square, here minus 1, that is equal to minus 1 by c. Is it fine? Now let us equate everything. What do we get? X1 by a square m is equal to, here minus minus will get cancelled, y1 by b square is equal to minus 1 by c. So if I equate these both, x1 is a square m by c, y1 is minus b square by c. Is it right? Then the coordinate is x1 comma y1 is equal to minus a square m by c minus b square by c. Right? Now let us substitute that in this equation or this equation, will get the condition. Is it okay? If I substitute in this, m into minus a square m by c minus into minus plus b square by c plus c is equal to 0. Now just see here, minus a square m square by c plus b square by c plus c equal to 0. If I take LCM as c, this will be minus a square m square plus b square plus c square is equal to c. So can I write this as c square is equal to a square m square minus b square? Yes. So this is a condition that this equation is a tangent to this hyperbola. Okay. What was in ellipse? It was like c square is equal to a square m square plus b square. What was in parabola? Just a by m. Right. And we also got this kind of point of contact in all those things also. Okay. So now can you just tell me what is equation of equation of tangent? The standard is y equal to mx plus c. If it is parabola, it is y equal to mx plus a by m. If it is ellipse, y is equal to mx plus or minus under root of a square m square plus b square. If it is hyperbola, we will write it as y is equal to mx plus or minus under root of a square m square minus b square. Is it? Did you understand? So what did we learn here? First thing, the condition that this form of equation is a tangent to this. From that we'll obviously write the equation of tangent. Is it clear? Fine. Shall we do problems on this condition? Let's do. See here, the question is, if 3x minus 4y plus k equal to 0 is a tangent to this hyperbola, then he is asking us to find the value of k. Okay, so Let me first convert both the things into standard form. X square minus 4y square is equal to 5 can be written as x square by 5 minus y square by 5 by 4 is equal to 1. Is it right? So here it is 4. We'll just write it in the denominator. Yes. So a is this. A square is 5. B square is 5 by 4. Right? Then next, we'll convert this into the form of standard y equal to mx plus c. That is 3x minus 4y plus k equal to 0. This will be 4y is equal to 3x plus k. Right? We'll just take this 4y that side. Then y is equal to 3 by 4x k by 4. 3 by 4x plus k by 4. This is in the form of y equal to mx plus c. M is 3 by 4, c is k by 4. Now what is the condition? That this equation is a tangent to this hyperbola is c square is equal to a square m square plus b square. Isn't it? So let us just substitute everything and simplify to find the value of k. Right? So c square k by 4 whole square, a square is 5, m square is 3 by 4 whole square, b square itself is 5 by 4. Right? So let me simplify. K square by 16 is equal to 5 into 9 by 16 plus 5 by 4. K square by 16 is equal to LCM is 16. 9 5s are 45. 5 4s are 20. Is that right? Here LCM is 16. Here 5 4s are 20. Now these both will get cancelled. What is the value of k? 20 plus 65. Therefore the value of k is root 65. Is that right? Once again see here. We'll just convert this in the form of standard hyperbolic equation. We'll write a square b square. Again then we'll write this equation in the standard slope intercept form. We'll write what is m, what is c. Substitute in the condition. What is this? C square is equal to a square m square minus b square. So don't get confused about these basic things. Okay. 45 minus 20 is 25, which is the answer is 5. Is that right? So these are the things you have to look into perfectly. Okay. Next, find the equation of a tangents to to a hyperbola which are parallel and perpendicular to this equation. Okay. What is the formula? Formula is y is equal to mx plus or minus under root of a square m square minus b square. So we have to find a square b square from this, m and c from this. Yes. Then 3x square minus 4y square is equal to 12. If I divide it by 12 for everything, I will get it as x square by 4, y square by 3 is equal to 1. 3 1s are 3 4s are 4 1s are 4 3s are. Is it? So what is a square here? A square is 4, b square is 3. Done for that. Let us see from this. Y is equal to x minus 7. Obviously it is m is 1, c is minus 7. Is it? Now let us substitute in the formula. First one, parallel to y equal to x minus 7. So the slope is obviously 1. Instead of m we have 1 here. Then the equation is y equal to 1x plus or minus under root of a square m square plus b square. 4 into 1 square minus b square. 4 minus 3 is 1. So the equations are y is equal to x plus or minus 1. These are the equation of tangents which are parallel to this equation. Right? Then what about the perpendicular condition? Perpendicular to y is equal to x minus 7. So what will be our slope? Minus 1. right? The slope is 1, the perpendicular will be minus 1 by that slope, which is minus 1. Yes, so the equation is y equal to mx plus or minus under root of a square m square minus b square. Obviously here it is minus 1 cos square will get this term. Therefore this is y equal to minus x plus or minus 4 minus 1 is again 1. So this is my equation of tangents perpendicular to this equation. Are this easy? Shall we go to the next problem? Let's do. Till now we discussed about equation of tangent which is in the form of y equal to mx plus c. What if it is in the form of lx plus my plus n equal to 0? How the condition will change? Let us do that. That is, let p of x comma y be the point on our hyperbola x square by a square minus y square by b square is equal to 1. Right? Now let us find the tangent for that. Equation of tangent is s1 equal to 0, that is xx1 by a square minus y1 by b square is equal to 1. Right? Let us bring that 1 this side. What do we get? Minus 1 equal to 0. This is my equation 2. Equation 1 and 2 represents the same. Equation 1 and 2 represent same. Then we'll just divide it. x1 by a square by L minus y1 by b square is equal to m minus 1 by n. x1 by a square by L minus y1 by b square by m is equal to minus 1 by n. Right? Do the same thing. x1 by a square L minus y1 by b square m is equal to minus 1 by n. Is it fine? Now what will be the point here? x1 is equal to minus a square L by n. y1 is equal to minus minus will get cancelled. I will get it as b square m by n. Now let us substitute this x1 and y1 in any one of the equation. Let us substitute in this. That will be L into x1 plus m into y1 b square m by n plus n is equal to 0. Is it? Then if I take LCM as n, this will be minus a square L square by n plus b square m square by n plus n is equal to 0. If I take n as LCM, a square L square plus b square m square plus n square is equal to 0. So what is the condition here? N square is equal to a square L square minus b square m square is the condition. Is it right? It is almost similar to the basic equation. Is it okay? Fine. Shall we go to the next concept? Let's do. The next thing we are going to discuss is parametric equations. In the recent sessions of ellipse also we discussed that for x square by a square plus y square by b square is equal to 1. We know that since it is square, since it is in the plus, we can write as a sin b cos. What if it is like minus? Same trigonometry, use the other terms. Can I write x as a secant theta, y is equal to b tan theta? Yes, right? So if you substitute here a square secant square, b square tan square, b square a square will get cancelled. I get a secant square minus tan square which is 1. Right? Are they satisfying? Obviously we can do this kind of things. Fine. Shall we find the tangent and normal for this? See here. Tangent for this is x1 by a square minus y1 by b square minus 1 is equal to 0. Right? So this is x1, this is y1. x into a secant theta by a square y into b tan theta by b square minus 1 is equal to 0. b, a will get cancelled. I will be left with x by a secant theta minus y by b tan theta minus 1 is equal to 0. This is the equation of tangent. What about the normal? Let us find the slope from this and let us use this point and find the normal. Okay. If I take the slope here, minus x coefficient by y coefficient minus secant theta by a by minus tan theta by b, which is nothing but minus minus b by a secant theta by tan theta. Right? What is the perpendicular slope here? Minus 1 by m is minus a by b tan theta by secant theta. Okay, minus a by b tan theta by secant theta. Now just tell me what is the equation of normal. Y minus y1 is equal to m into x minus x1. Okay. If you want to simplify this, you can simplify, or else if you want to put like this, it's okay. Okay. If you want to simplify, this will be like you can write tan as sine by cos. Here also sine by cos, sine by cos. I mean 1 by cos. Cos will get cancelled. I will be left with sine. Okay. You can multiply each and everything and simplify further. Okay. So what do we get here? If I write tan as y minus b into sin theta by cos theta is equal to minus a by b sin theta by cos theta by 1 by cos theta into x minus a by cos theta. Here these both will get cancelled, right? And here y cos theta minus b sin theta. Let me multiply this b also here itself, or else shall we multiply again? So this is equal to minus a sin theta by b into x cos theta minus a, here whole divided by cos theta, here whole divided by cos theta. Both will get cancelled. Now let's multiply this side. What do we get? yb cos theta minus b square sin theta is equal to minus ax sin theta cos theta plus a square sin theta. If you simplify more, you will get more kinds of things. Is it okay? This is one thing you have to remember, and one more last topic in this hyperbola thing is asymptotes. These are simple, but in some cases this term is used a lot. What are these asymptotes? Asymptotes is a basic word, but it is nothing but a tangent at infinity, right? We know that this is an hyperbola. It will go somewhere else, but we don't know where does it touch the hyperbola. It touches somewhere at infinity. So these asymptotes are actually very important in our future classes, but as of now, as of our intermediate, just asymptotes introduction is very important. That is, asymptotes are nothing but the tangents of hyperbola at infinity. Okay. So the two things we are going to learn here is how do we find the asymptotes. Let us say there is an equation like this: 4x square minus 9y square is equal to 36. Okay, can I factorize it? Yes, a square minus b square, that is nothing but 2x. Okay, let me simplify and write it first. X square by 9 minus y square by 4 is equal to 1. Can I write like this? So if I separate it, I will get it as x by 3 plus y by 2 into x by 3 minus y by 2 is equal to 1. So these two equations are considered to be equations of asymptotes. Okay, this question we solved it very simply, but few questions we can't solve or factorize it. Okay, fine. And one more thing you have to remember in this is the angle between these asymptotes. Okay, the angle between these asymptotes is always given by 2 tan inverse b by a. This is one simple formula you can remember. Okay, fine. By this few basic things we can end the chapter hyperbola. What all we learned? We started with hyperbola's basic and the difference with its ellipse. Then we did few problems of how do we solve the hyperbola, how do we find the equation of hyperbola, right? Then we discussed about hyperbola and conjugate hyperbola, right? Then equations of tangents, normals in different forms, derivations, problems, then few more concepts like asymptotes. Okay, fine. By this thing we can also end our 2B, that is our maths 2B of our inter-second year. Clear? Hope everything is clear for you. Fine. Okay, this is Sai Prasad. Thank you.